The title of today's topic is Climate Simulation, and we will introduce an Urban Multi-Scale Urban Environmental Predictor, or UMEP. UMEP is a city-based climate service tool. It combines models and tools essential for climate simulation. It is an open-source tool designed to be easily updated as new data and tools are developed, and to be accessible to researchers, decision-makers, and practitioners. The reports of extreme weather events, such as heat waves, are becoming more frequent. Urban areas are particularly vulnerable to those extreme events due to the concentration of population and human settlements. To understand how weather and climate affect the urban inhabitants, and a common toolbox for all stakeholders is needed. Planning decisions for a city which affect different aspects of city life, such as transport, energy demand, and water supply, can be better informed by a tool for climate-related service. What are the criteria of a common toolbox that can be used and accessible to researchers, decision-makers, and practitioners? It will have to consider all aspects. For example, integrated hydroclimatological models are needed. Not only water management. The scale of analysis needs to be flexible both in temporal and spatial dimensions. We also need a model that can handle feedbacks, taking care of complex interactions, for example, effect of water on heat exchange as well as flooding. UMEP is an integrated tool for urban climatology and climate-sensitive planning applications. It is a city-based climate service tool that combines models and tools essential for climate simulations. UMEP is being developed as a community open-source tool. It can be used without restriction with respect to cost, license, or rights issues. It includes tools to enable users to input atmospheric and surface data from multiple sources, to characterize the urban environment, to prepare meteorological data for use in cities, to undertake simulations and consider scenarios, and to compare and visualize different combinations of climate indicators. Additionally, it is designed to be easily updated as new data and tools are developed. The processor is the modeling system. For examples, the Urban Land Service Model, or ULSM. Then, the post-processor that provides the climate services. It represents the tools to analyze the outputs, individual case and ensemble, as well as the indicator of uncertainty for user applications. Each element is described in detail in the online manual at the urbanclimate.net website. For climate services, there are specific and indispensable applications, such as the identification of heat waves and cold waves, the impact of green infrastructure on runoff, the effects of buildings on human thermal stress or health, solar energy production, and the impact of human activities on heat emissions. In addition, UMEP has broad utility for applications related to outdoor thermal comfort, wind, urban energy consumption, and climate change mitigation. For reference, we have included the link to Lindbergh's 2018 paper, which describes the motivation and realization of the climate modeler UMEP. The second link is the introduction of UMEP in the European Commission's Climate Adapt webpage. Here is the link to the online manual and tutorials. In Practical 3, you will finish all mandatory tutorials.